Look, it's about the development of AI. Right now, I think the first dimension is the vertical dimension, meaning your intelligence level is constantly improving. This is mainly reflected in the current way AI responds, which is essentially about how well these text models can perform. And then the second is this kind of horizontal development. Besides text models, as Mr. Zhang just mentioned, there are also various other modalities. These modalities are also undergoing horizontal development, which is mainly about enabling your model to have more skills and to accomplish more tasks, while also combining with the vertical development of intelligence. Actually, in both of these dimensions, I think we've seen tremendous progress. For example, in the vertical dimension, well, the performance has been continuously improving, right? For example, if we look at mathematical competitions, the math abilities, last year, the results might have been a complete fail. But this year, it might already be able to score over 90 points. And it's basically the same with coding. It can outperform many professionals. These programming experts, and as a result, many new application opportunities have emerged. For example, tools like Cursor, which are quite popular now. This kind of software, which allows you to write code directly using natural language, is also becoming more and more widespread. So I think this is actually the result of a lot of technological advancements. And if we look at many specific technical metrics, for example, take the context length supported by current language models. If we look back to this time last year, most models could only support 4,000 to 8,000 tokens. But if you look at it today, you'll find that 4,000 to 8,000 is already considered a very, very low number, right? Now, 128,000 has basically become standard, and there are already many models that can support even more, or even models that support M-level long text lengths. So this is actually a very important foundation for the continuous improvement of intelligence going forward. And many of the recent advancements are not just about scaling. For example, scaling will, of course, continue. Moreover, many advancements actually also come from, for example, optimizations in your post-training algorithms and improvements in your data. These optimizations actually have shorter cycles, so the shorter cycles further accelerate the overall pace of AI development. Many of the recent advancements we've seen in mathematics, for example, have also benefited from the development of these technologies. Horizontally, of course, there have also been many new breakthroughs, including, well, Sora is probably the most influential one, having achieved video generation. And recently, there have been a lot of new products and technologies emerging. For example, now you can basically take a research paper and directly generate something where you can hardly tell if it's real or fake. For instance, a podcast, a two-person conversation, something like that, which is an example of this kind of cross-modal transformation. Interaction and generation are actually becoming more and more mature. So I think overall, we're really in the midst of this acceleration process.
It feels like these technologies are still accelerating in their expansion, bringing about changes and innovations. Although, from an objective standpoint, it may seem like we have not seen the emergence of another super app. If we set aside the perspective of looking for a super app and instead focus on the technology itself, we can actually see its real progress. This might be a more rational and objective viewpoint. So I would also like to hear, Professor Zhu Jun, how would you summarize the past 18 months, specifically in terms of AGI technology? What kind of developments has it gone through, and what milestones or stages of progress can we summarize?
Yes, actually, when it comes to AGI, what everyone is most focused on is still large models, large language models. As both of you just mentioned, last year and even this year, there have been many significant changes in this area. And overall, I completely agree with what was just said about the pace of progress accelerating. Additionally, I'd like to add one more point. Actually, right now, that is, when everyone is working on this, like when I'm analyzing problems or something, the speed is actually increasing as well. We can say that the learning curve is becoming steeper. For example, if you look at language models, it probably started around 2018, right? Maybe 400. They were among the earliest to work on this. Up until last year and roughly up to this year, it's been about 5 or 6 years along this path. But actually, starting from last year, in the first half, everyone was still focused on language models. And in the second half, the discussion shifted to multimodality, from multimodal understanding to multimodal generation. Now, if we look back, for example, at images or videos, especially videos, the most striking thing actually happened around February this year. At that time, many people were truly shocked. I think that often people wondered whether this technology was really possible, because a lot of it wasn't made public. There was a lot of discussion about how to make breakthroughs, right? But in fact, what we see now is that within about half a year, the industry has already achieved it. It's already usable. Moreover, it has achieved very good results in terms of spatiotemporal consistency. So this progress took about half a year. I think the core reason for this acceleration is that everyone now has a much better understanding and preparation for this approach. Of course, there are also physical conditions, such as cloud infrastructure and the preparation of computing resources. It's not like when ChatGPT first came out, when people were at a loss. I think many were not ready, not prepared to accept this. So a lot of time was spent in the middle learning and mastering it. Once we had mastered it and then saw further progress, tackling new problems became faster and faster. Of course, depending on the specific capability, the speed at which it reaches actual users can vary. Some are faster, some slower, and it also depends on the industry. From a broad perspective, like people might not have noticed this, but from a technical standpoint, I actually feel that the progress curve is getting steeper and steeper. And if we try to predict the future, there could be a lot more to come. This includes the development of higher level AGI, for example. I'm quite optimistic and think we might see it realized at an even faster pace than before.
From the three of your perspectives, if someone from the outside says that AGI development is slowing down, your simple response might be, what more do you want? These past 18 months have already left all of us overwhelmed by the pace of its development. Speaking of this, the recently released O1 model has had a significant impact among professionals, in my opinion. There are still a lot of lively discussions going on. Since we're all here on this stage and each of you has your own insights on this matter, let's take this opportunity to discuss it. Let me start by asking Daxin, what do you think about O1? Many people consider this an important step forward in the development of AGI. How should we really understand this progress? For me,
I do see that there are some differing opinions. Some people think it's very significant, while others feel it's nothing special. I think if you actually try using O1, your first impression will probably be that its reasoning ability is truly impressive. We've tested a lot of queries ourselves and found that its reasoning capability has indeed taken a big leap forward. So then we started to think about what the real significance behind this is. I can think of 2 points. The first is what I just mentioned. For the first time, it proves that a large language model, can actually possess the human brain's slow thinking, that is, a capability like System 2 in cognitive science. Because compared to the previous GPT paradigm or GPT training, which is called predict the next token, if it is only trained in this way, it is destined to only have System 1 capabilities. But OE uses a reinforcement learning training framework, which brings about System 2 capabilities. So what about System 1? It is characterized by linear thinking. Although we see that GPT-4 can sometimes break down a complex problem into many steps and solve it step by step, it is still linear. The biggest difference between System 2 and System 1 is that System 2 can explore different paths. It can reflect on itself, correct its own mistakes, and keep trying and failing until it finds the right path. So this is the characteristic of System 2. Therefore, with this OE, I think it combines previous imitation learning and reinforcement learning, enabling a model to possess both System 1 and System 2 capabilities similar to the human brain at the same time. From this perspective, I believe its significance is tremendous. The second point, I think, is that it brings a new direction for skating log. My understanding of this OE is that it is actually trying to answer a question. How can reinforcement learning truly generalize? Because reinforcement learning is not new, right? DeepMind has always followed the reinforcement learning path from AlphaGo to AlphaFold to AlphaGeometry. In fact, they are extremely strong in reinforcement learning, but previously reinforcement learning scenarios were all designed for specific tasks. AlphaGo could only play Go, and AlphaFold could only predict protein structures. So the emergence of O1 this time marks a major leap in the generality and generalization capabilities of reinforcement learning models. So I think, moreover, they have scaled it up to a very large scale. That's why I see this as a new paradigm in technology brought about by scaling. We might as well call it I/O scaling. And what's interesting is that OE is actually not at a very mature stage yet. It's still just the beginning. But I think that's precisely what makes it so exciting. It's as if OpenAI is telling us, hey, I found a path with a very high ceiling. And if you carefully think about the underlying method behind it, you'll believe that this path is actually viable. So in terms of capability, I think O1 has demonstrated that language models can possess System 2 abilities. From a technical perspective, it has introduced a new scaling paradigm, so I think its significance is still very substantial.
It sounds like, even though you say there's currently no consensus, you seem to be very optimistic and very much in agreement. So let me hear what teacher Ju Jun thinks. What do you think about O1 and the progress it has brought at this stage? How would you evaluate the significance of its progress?
Yes. My view is still that it represents a significant qualitative leap because we have also done some categorization of AGR. In academia and industry, everyone uses this L1 to L5 grading system. Actually, L1 is basically what we call a chatbot, like ChatGPT, and the many dialogue systems people have worked on before. L2 is actually what we call a reasoner. It can perform deep reasoning and complex problem solving. And then L3 is what we call an agent. This is actually to respond to what Mr. Wu just mentioned about moving from the digital world to the physical world. If I want to change it, I need to interact with it. Then L4 is called an innovator. Its purpose is actually to discover or create something new or to uncover new knowledge. L5 is the organizer, which can coordinate or use certain organizational methods to operate more efficiently. So this is a classification of AGI from L1 to L5. Of course, at each level, there is also a distinction between what we call narrow and general. For example, you might currently demonstrate certain abilities on specific tasks, like what we see now. For example, OI has actually already achieved L2 level narrow intelligence in certain specific tasks, reaching a very advanced level of human-like intelligence. From the perspective of this classification, I think it truly represents a huge leap forward for the entire industry. But just now, from a technical standpoint, Mr. Zhang also mentioned that, in fact, what it does is essentially take what we previously had, such as reinforcement learning or other technologies, and actually applies them in a lot of things that have already been done in research. But in reality, being able to scale it up and achieve results on top of this large-scale foundational model is still a significant breakthrough for the industry, both from an engineering and implementation perspective. Of course, it will also trigger or inspire a lot of future exploration and practical R&D. It may move from narrow to general in this process. This kind of leap, I think, as I mentioned earlier about the speed, I believe it could happen very quickly because a lot of groundwork has already been laid. I also look forward to seeing this field achieve even better results at the L2 level and perhaps even higher level advancements.
It seems like your definition is already set quite high. In reality, we've already seen a clear and significant path and some phased achievements at the L2 level. That is the L2 level of AGI, right? Previously, everything was still at the L1 level. Of course, to reach Mr. Wu's expectations of embracing the change in the physical world, we ultimately need to go further, right? Once we reach L3, perhaps that's when things will truly and systematically happen in a complete way. So I'd like to come back to Zhilin here. After the release of Omni this time, Sam Altman also enthusiastically said, "We believe this is a new paradigm revolution." Of course, Sam is very good at giving speeches and expressing himself. We'd like to hear your thoughts on this. How should we understand his statement that this is a new paradigm shift? Do you agree that this is indeed a paradigm shift?
I think what he said is indeed very significant. The main significance lies in raising the upper limit of AI, that is, the upper limit of what AI can achieve. Whether you're talking about improving productivity by 5% or 10% or increasing GDP tenfold, I think the most important issue here is whether you can further scale through reinforcement learning. So I think this is something that completely raises the upper limit of AI. If we look at the 70 or 80 years of AI development history, the only thing that has truly worked is scaling. The only thing that has truly worked is adding more computing power. But before O1 was proposed, actually, there were probably already many people researching reinforcement learning. But there wasn't really a definite answer whether reinforcement learning, when integrated with large language models or with current pre-training and post-training methods, can continue to drive improvement. Because I think, for example, the improvements in this generation of models like GPT-4 are more of a deterministic improvement. Using the same approach, just scaling it up, there will definitely be a predictable improvement. But I feel that the improvement